Today's my lecture topic is gas turbine heat recovery. In the gas turbine heat recovery, the waste heat recovery system is a critically important subsystem of a cogeneration system. In the past, it was viewed as a separate add-on item. This view is being changed with the realization that good performance, both thermodynamically and the terms of reliability, grows of the designing the heat recovery system as an integral part of the overall system. The gas turbine exhaust gases enter the heat recovery system generating where the energy is transferred to the water to produce steam. There are many different configurations of the HRSG units. Most units are divided into the same amount of sections as the steam turbine. In most cases, each section of the HRSG has a preheater, an economizer, and feed water, and then a superheater. The steam entering the steam turbine is superheated. The most common type is in a large combined cycle power is the drum type with forced circulation. These types are vertical. The exhaust gas flow is vertical with horizontal tube bundles suspended in the steel structure. The steel structure of the supports the drum. In a forced circulation, the steam water mixture is circulated through evaporator tubes using a pump. These pumps increase the parasitic load and thus detract from the cycle efficiency. In this type, the heat transfer tubes are horizontal, suspended from uncooled tube supports located in the hot gas path. Some verticals are designed with evaporators which operate without the use of circulation pumps. The ones through steam generators are finding quick acceptance due to the fact that they have smaller footprints and can be installed in a much shorter time and a lower price. The ones through steam generators, unlike the HRSGs, do not have defined economizer, evaporator, or superheater sections. The water enters at one end and steam leaves at the other end, eliminating the drum and circulation pumps. Location of the water to steam interface is free to move depending on the total heat input from the gas turbine. The flow rates and pressures of the feed water in the tube bunk, unlike the HRSGs, the ones through units have no steam drums. Some important points are observing in the waste heat recovery are multi-pressure steam generators. These are becoming increasingly popular. With a single pressure boiler, there is a limit to the heat recovery because the exhaust gas temperature cannot be reduced below the steam saturation temperature. This problem is avoided by the use of multi-pressure rivers. Pinch point. This is defined as the difference between the exhaust gas temperature leaving the evaporator section and the saturation temperature of the steam. Ideally, the lower the pinch point, more heat removed, but this calls for more surface area and consequently increase in the back pressure and cost. Also, excessively low pinch points can mean inadequate steam production if the exhaust gas is low in energy. General guidelines call for a pinch point of 15 to 40 degree Fahrenheit. The final choice is obviously based on economic construction. Approach temperature is defined as the difference between the saturation of the steam and the inlet water. Lowering the approach temperature can result in increased steam production, but as increased generation takes place in the compression.